Hello again, this is Dr. James Camp from Lee College in Baytown, Texas, and this is the 6th lesson in my Starting Off in C++ series where I introduce you to C++ vectors. Now you may ask why vectors and not arrays. Arrays are simpler and they're sort of common to all the different programming languages, but the fact is people who write in C++, at least for the purpose that I'm going at today, building a list, as you read in data, are going to use a vector. You're not really going to dynamically allocate a array or allocate a huge array and then fill in a portion of it like they teach you in the C++ textbooks. You're going to use a vector. So today's project is an improved version of the grade stats program. If you recall, what we wanted to calculate before was average grade. We did that. High and low grades. We did that. Standard deviation. We mentioned that we needed to know arrays and vectors. And median score. We mentioned again that we needed to know arrays and vectors. Well, guess what? Today we're going to learn how to use vectors. So we're going to learn how to do the standard deviation and the median. Okay, so again, our first things first approach, what we need to do to make this program work. We need to ask the user to enter pairs of numbers, calculate the grade percent. As before, we add the grade percent to a total so that we can find the average. But this time we're going to add grade percent to a vector. After we leave the input loop, we're going to find the grade average by taking the grade percent total and dividing by the size of the grade vector. So the grade vector is going to keep track of how many grades we have for us. We don't have to have an extra variable to do that. Then we're going to step through the whole vector. Okay, that's going to require a for loop to find the standard deviation. Now, in case you don't know, standard deviation is the square root of the sum of the squares of the differences between each individual value xi minus the average x. Okay, so grade minus grade average squared, or in C++ terms, POW of parentheses grade minus grade average, comma 2. Oh, and then that whole sum is divided by n, the number of grades. So after we leave the loop, we're going to take the square root of the sum divided by grade vector dot size. Make sure you put the divided by size inside the square root, not outside the square root, or you'll get the wrong number. Okay, and then finally, we want to find the median grade. Median is defined as the middle value when the list of values is sorted. Okay, so we need a way to sort the grades. Fortunately, C++ has an algorithm for that called sort, a function called sort in the algorithm header. After we sort, if there's an odd number of grades, median is simply the middle value. So we take grade vector dot size divided by 2 and use that as the lookup value. If there's an even number of grades, we have to average the one that's just before the midpoint, which is grade vector dot size over 2 minus 1, with the one that's right after the midpoint, which is grade vector dot size over 2. If you doubt that value, if you doubt those calculations, make a list of about 6 numbers and number them 0, 1, 2, 3, 4, 5, the indexes in a C++ vector, and you'll find that size over 2 and size over 2 minus 1 are the two middle values that you have to average. Okay, so what I want you to do is start with the grade stats program we did last time, and we're just going to modify that program as we go through. Okay, first we need to add the CMath header to get POW and square root, and of course we need to add the vector header to get vectors. Okay. Now, what is a vector? Okay. A vector is like a resizable array. Okay. What's an array? An array is a list of values that take up a continuous set of memory locations. So um, a single variable name can point to a whole list of values. In fact, list is almost a better name for this, and in Java, this is called an array list. A vector in Java, the equivalent of a vector is called an array list. In C Sharp, it's simply called a list. Okay, so um, vector is sort of a weird name, and I'm not sure why C++ chose to use vector instead of some variant on list, but I think it has to do with um, computer science definitions of list in which there are other data structures that are considered lists as well. C++ wants to be nothing if not precise when using its computer science terms. So how do we define a vector in C++? We put the keyword vector, and then in what's called diamond notation, you put an angle bracket, a type name, and another angle bracket. Where type could be double, int, string. You could have a vector of vectors. Any valid type can go inside those angle brackets. Then we give the vector a name, and if we want it to be initialized as an empty vector, we simply put a semicolon. If we want it to be initialized with a list of values, we put that list of values inside curly braces as what's called an initialization list. Okay. We no longer need the num grades in our main program because the vector is going to count them for us. But we do need to declare our vector. So our int main now starts like this, vector angle bracket double, and we're calling it grade vector. We take our first input exactly like the Lesson 4A grade stats program, so I'm not going to comment on this. The difference comes in processing our first input. We calculate the grade percent the same way. We assign the first grade percent to be both minimum and maximum, just as we had before. We add the grade percent to the sum, but then we use this funny member function called pushback. Okay, pushback is a member function of every vector object. You know it's a member function because it's joined with that dot. You use the dot notation, grade vector dot pushback. And you can think of it as an add to list function. In fact, again, in C Sharp, the equivalent function is simply called list.add. So, C Sharp is a little bit more user friendly than C++, but it's also not a very good first language to learn for a number of reasons. So we're starting in C++, where we get stuck with pushback. Okay, but you can think of pushback as the add function. So what we're essentially doing is taking grade percent and adding it to the back of the grade vector list, adding it to the last position in the grade vector list. The input loop similarly has one change to it. We calculate the grade percent, we calculate the min and the max and the sum, and then once again we push back the grade percent onto the grade vector for every new grade that comes in. By the time we're done, grade vector will hold a list in memory of every grade percent that we've calculated. We calculate the average almost exactly as before, except since we haven't been keeping track of how many grades with the num grades variable that we did last time, we're just going to let grade vector count them for us. So we'll say grade vector dot size. Again, size is another member function of every vector. Okay, as such, since it's a member function, don't forget the parentheses after the name. That's a very common error, is to just try to type grade_vector.size semicolon and not grade_vector.size open paren, close paren, semicolon. Then we're going to loop through to calculate standard deviation. This is a fun special case of the for loop, sometimes called a for each loop. Again, in C#, it's actually called for each. Grade percent takes on each value from grade vector one at a time. Okay, so each run through the loop, grade percent is assigned a different value from grade vector. And by the time we've run through the entire loop, grade percent has sampled every single value in grade vector. Note that standard deviation is based on a type of statistic called a sum squared error. Okay, you take the error, the difference between the actual grade and the average, and you square it. The reason we do that is to make sure that the sum is a sum of positive numbers. Okay, we could do the absolute value, but what statisticians have always done instead is to use the square. And that turns out to have special properties with respect to normal distributions, so it works out very nicely. Finally, to get the to get the standard deviation in the same units as the measurement, since the sum is a sum of squares, we then have to take the square root to get it back into the original units. Otherwise, you'd have this hugely blown up standard deviation that wouldn't be relevant to the grades anymore. Okay. To get the median, first we need to sort the list. Okay, fortunately C++ has a function that does that for us called sort. And all you have to do with sort is, well, first you have to include the algorithm header, and then you pass it the beginning point of your vector and the ending point of your vector. And again, vector has member functions that look up those beginning points and end points, so you don't have to do any complicated pointer manipulation that you would have to do with an array. Once the list is sorted, we simply have to pick out the middle value. Okay. The first thing I'm going to do is, since size isn't changing anymore, I'm going to store grade_vector.size as an int called size to avoid having to type grade_vector.size over and over and over again. That's just me being a lazy programmer, but it also makes my code look a little more readable in this case. If size is odd, okay, we're simply going to pick the middle value, which happens to be size divided by 2. Because we're doing integer division, that's essentially dividing by 2 and rounding down. If it's not odd, we have to take the 2 middle values and average them together. Finally, we format the output. The differences between this and last time is that we're adding standard deviation as a plus or minus to the average, okay, which gives you kind of a range of how, a range of values where the average might actually lie, or a measure of what we call central value, okay, in statistics. So 68%, I believe, of the grades fall between average minus SD and average plus SD. So average plus or minus SD gives you a prediction of where most of your grades are going to lie. We give a median grade, which we just looked up from the sorted list. Here's what this looks like in sample output. We take 5 different grades. The average grade is an 82. plus or minus 9.14, which means that my grades should be roughly between a 73 and a 91. Okay. But my low is actually a little lower than that, and my high is actually a little higher than that, which if you understand the way bell curve distributions work, there's always a little bit below that and a little bit above that middle range. And the median grade was an 80. You always want the average and the median to be very close to each other, otherwise that means that the distribution is skewed somewhat and you're not getting reliable numbers. Okay, summary, what have we learned today? We learned how to define a vector. Okay, we learned some important member functions, pushback that adds a new entity to a vector, size that tells us how big the vector is at the given moment, begin and end that are used with the sort function. We learned the novel for each loop, which works exactly the same way, by the way, in Java, but has a slightly different implementation in C# called a for each loop. And we learned how to use the C++ sort function to get a sorted list. Okay, that's it for now. I'll have a vector practice assignment for you to work on back on the Blackboard page. So go get to it. Good luck and happy programming.